In this video, we are going to learn about the molar volume of gases. Knowing the molar volume of gases, that is the volume that 1 mole of any gas occupies, might not seem important to you at present, but as a global community, we need to know the amount of carbon dioxide or other gaseous pollutants that are being produced by human activity. This is so we can monitor climate change due to global warming or the effects of other gaseous pollutants on our health. Can you think of 2 common gaseous pollutants? Pause and continue when ready. The main answer is usually carbon dioxide, a major greenhouse gas, which comes from the burning of fossil fuels, so petrol in cars or from fuel burnt in power stations. Other gases that have a negative effect on your health include nitrogen oxides. These gases come from fuels burnt in cars, or sulfur dioxide, which also come from fuels in cars and come from burning of fossil fuels in power stations. Did you guess any of these gases? These are the major ones. There are sadly others. Fortunately, the molar volume for a gas, whether that gas is a pollutant or not, is always the same. Scientists have found that 1 mole of any gas occupies approximately 22.4 litres per mole under standard temperature and pressure. Standard temperature and pressure is 0 degrees centigrade and 0.986 atmospheres respectively. Scientists also quote molar gas volumes at 24 litres per mole, but this is at room temperature and pressure, which is 20 degrees centigrade and 1 atmosphere pressure. Can you think why the molar volume of a gas changes when it's measured at different temperatures and pressures? Pause, think, and continue when you're ready. In terms of temperature, the answer is that a gas expands when it's heated, so 1 mole of a gas would occupy a larger molar volume. Think about a balloon. If it's a hot day, the balloon sometimes pops randomly. This is because when heated, the spaces between the gas particles in the balloon expand until the balloon can expand no more, and bang, the balloon bursts. In terms of pressure, if a gas is in a sealed container and is put under a higher pressure than the atmosphere, then it occupies a smaller volume. If you squeeze an empty soft drinks bottle with a lid on, it proves this idea. When the bottle is squeezed and then released, the plastic bottle usually returns to its original shape. So, in summary, 1 mole of any gas is always approximately 22.4 litres per mole when measured at standard temperature and pressure, or is more usually quoted as 24 litres per mole when measured at room temperature and pressure.